So here are three restricted domains. These are the three domains that we're dealing with when we're dealing with inverse of cosine and inverse of tangent. If our answer gives us an angle outside of these domains, it's not a true solution. All right. Also, and I already told you guys this, but I want to make sure you're recording. If we have an answer of 7 pi over 4, this is not what we would put into math itself, because technically it's not between negative pi over 2 and pi over 2. Instead, we need to convert this into a negative angle measure. So the angle measure that is on this exact same point, this exact same angle, is just minus pi over 4. We're going down 1 pi over 4. So this is what we would put into math. All right, so now we can get into the actual examples, because I'm sure right now you guys are like, what the heck is she talking about? Which is fine, totally fine. Previously, on previous days of this year, we were or actually it was the last week, right? So previously, what we were doing, we were taking an angle, say, I don't know, like, let's we were taking an angle and finding the sine of that angle in order to know the y value of that angle, right? So sine of pi over 4, if I'm looking on my unit circle for pi over 4, the y value of that angle is square root of 2. That's what we were doing previously. Now we're doing the exact opposite. This is our x value and this is our y value. We're switching them. So if I'm trying to find the inverse, what I do is I'm taking the y value, the previous y value, and it's now my x value. So now what we're doing is we're looking at our unit circle for square root of 2 over 2 as the y value. Well, the angle that has that square root of 2 over 2 as the y value that is in my restricted domain is pi over 4. So we're just doing the exact opposite. Before, we took an angle to find the value. Now we're taking the value to find the angle. It's just another way to solve. It depends on what we're missing. So now we're going to be missing the angle, and we're trying to find the angle instead. Let's do it. Sine is always our what values? Good. I know on my unit, what I'm doing is I'm looking for a y value of square root of 2 over 2. Now there's 6. Where on my unit circle is there a y value of square root of 2 over 2? There should be two angles match this. A y value of square root of 2 over 2. Yes, there are two. Now you don't have to sketch it, but it might be good to relate to. We have pi over 4 has a y value of 2 over 2. We also have 3 pi over 4. Now we need to ask ourselves, which one of these is our true solution? Which one is in our restricted domain for inverse of sine? This pi over 4, not 3 pi over 4, not in our correct domain. So our answer here is pi over 4. That's what we would input into math itself. Let's do it again. Cosine, inverse of cosine. So this time we're not looking for y value. This time we're looking for x value. We're looking for x values on our unit circle that are negative 1/2. Where on our unit circle do we have an x value of -10? Should be two angles. Yes, he's the only one answering this. Well, no, we answered this. Yes, we have -1/2 of our x value on the 2 pi over 3, which is this angle right here, and also 4 pi over 3, this angle down here. Which one of these is my true solution according to my domain cosine? Yes, this is in our domain. This is not. So the answer here is 2 pi over 3, or that's 120 degrees. But we would put into Math Excel 2 pi over 3. Is this making sense? How do we find the restricted domain? That was what these up here, the 3 unit circles that I have highlighted portions of, those are always the restricted domains. So sine, inverse of sine is always from -pi/2 to pi/2. This one right here. Cosine, inverse of cosine is always from 0 to pi. Tangent is always from -pi/2 to pi/2. We're always having these exact restricted domains. So we're always referring to these exact domains. All right, so now let's look at this last part. Tangent inverse of -1. Tangent is tricky because it is sine over cosine values or y over x. Now, now we have gone over something like this previously. If we want y over x to equal -1, when is the only time that two things divide to equal 1? When the two things are the same. Now, I want to take -1. So if I have, like, say, -2 divided by -2, is that going to give me a negative answer? No. Instead, oh, so I put this. Instead, if one of them is negative, it would give us an answer -1. So I'm looking at my unit circle for the same x and y values, but one of them, it doesn't matter which, one of them, there are two. Whoa, what happened? Oh my. Where on my unit circle do I have the exact same x value as y value, but one of them is negative? So no, those aren't the same exact x and y values. Right, so we have 135 over 3 pi over 4, because the x is -square root 2 over 2, the y value is is square root of 2 over 2. Those two values divide to be -1, so that's a possible answer, 3 pi over 4. Or there's another one down here, because the coordinate point is square root of 2 over 2, comma, negative square root of 2 over 2. So those divide to give you -1. Which one of these is in my domain for tangent inverse of tangent? Just keep, stop it. Oh, I'm about to, what is it doing? Okay, really though, stop. Okay, so 7 pi over 4 is in our restricted domain. However, this is what I was talking about. Technically, my restricted domain for tangent is between negative pi over 2 to pi over 2, meaning that all of the values less or lower than 0, it wants to be the negative version of that angle. So we have to think, what is the negative version of this point? This is not our answer. I'm going from 0 down pi over 4. So the negative version of this angle is actually negative pi over 4. Does everyone see how we got that? Not really. So if we're thinking about this entire unit circle in terms of 4, if I was to go all the way around the circle, this 0-degree angle could also be written as 8 pi over 4, right? That's going to come down to 2 pi. You know, a whole circle is 2 pi. So if I'm thinking of this point as 8 pi over 4, to go down to 7 pi over 4 is just 1 pi over 4 less. 7 pi over 4 is 1 pi over 4 less than 8 pi over 4. So we're subtracting a single pi over 4 to get to that point. Right? I'm moving clockwise. Yes. That's all we're doing. Instead, 7 pi over 4 is technically going all the way around the circle, right? We want it in terms of the negative direction. Okay, you get it. Good. It's just 1 pi over 4 less 1 pi over 4 clockwise. So we say negative pi over 4. That's my negative pi over 4. That's what we'd have to input into math. Whoops. Unfortunately, oh my gosh, let's shoot this thing. Stop it. Why is that to me? Okay. So unfortunately, if we tried to put 7 pi over 4 into our Math Excel, it would mark it wrong. I didn't know that Math Excel did this until recently. So I'm making sure to hit this hard because people are going to be confused by it. So I want them to come back and watch this video. We have to input negative pi over 4 for it to be marked correct in Math Excel. All right. So now moving on to the next section. Oh, I also want to mention just really quickly, whenever it's a sign like this, it's just another way to write inverse of sine. It's just another quick way to write inverse of sine. This part E would be inverse of sine of negative 1/2. E would be inverse of sine of 1, and F would be inverse of cosine of negative square root. All right, so now let's do the next section, which is adding on to what we just learned. Now here, this is actually a composition. It's a function inside of another function. Whenever we're dealing with a composition, a function inside of another function, you always work on the innermost parentheses first. So first we have to figure out what sine of 5 pi over 6 is equal to. So if I'm looking on my unit and I'm finding an angle 5 pi over 6, at that angle, where is it? It's 150 degree angle. At that angle, because I'm dealing with sine, you know you're looking for equal y value. So at the angle 5 pi over 6, the y value is 1/2. So this whole thing is equal to 1/2. And now that I have figured out what sine of 5 pi over 6 is, now you find the sine inverse of 1/2. So again, we know that sine is our y value. I'm looking on my unit circle for when my y value is a half. Now I know you're saying, oh, well, 5 pi over 6, what we just found, has a y value of a half. But what's wrong with that is wait, how did you get a half? Because if I'm looking for 5 pi over 6, this is what we did last week. If I'm looking for 5 pi over 6 on my unit circle, so I'm finding 5 pi over 6, it's that 180 degree angle. If I'm finding the sine of 5 pi over 6, that's the y value of 5 pi over 6. So the y value of 5 pi over 6 is half. So the sine of 5 pi over 6 is half. Okay. Now we're finding the inverse sine of a half, meaning we're looking at the unit circle for where the y value is a half. Well, that's what we literally just did, right? We literally just found the y value of 5 pi over 6 is a half. So if I'm looking for the y value that's a half, it would give me 5 pi over 6. But there's an issue answer. What's the issue? Ah, yes, Kate. 5 pi over 6 is not in my restricted domain for sine. So I need to find another angle that has a y value of 1/2. Yes, Samantha, I agree. This has a y value of a half. And is it, oh, I wrote 5 over 2. Is that in our restricted domain for sine? Yes. So this is our answer. And I'm done. Does that make sense? So if I instead, as an example, had inverse sine of pi over 3, because pi over 3 is in your restricted domain, your answer is just pi over 3. If the angle that they give you, it's the inverse of the exact same function, if the angle they give you is in the correct domain, you can just cancel out the inverse and the original, and it is left with the angle. But because in this real example, in this part A, because 5 pi over 6 is not in the restricted domain, it's not our final answer. We have to find another angle. But doesn't pi over 3 have an x? Oh, shoot. Thank you. It's not pi over 3. I drew the right angle, but what is that angle actually? Oh my gosh. I'm looking for y value of pi over 6, 6, 6. Thank you for catching that up. My goodness. Pi over 6 has the y value of That's okay, Samantha. We were just rolling with it. No worries. All right, we do another one. Cosine. All right. So cosine of 5 pi over 6. Remember, we want the innermost parentheses first. So I'm first finding the cosine of 5 pi over 4. We know that is the x value. So I'm looking for the x value of the angle 5 pi over 4. So let's see. 5 pi over 4 is that 225 degree angle. The x value for 5 pi over 4 is negative square root of 2 over 2. That's what that entire cosine of 5 pi over 4 is replaced with. Well, and now we're finding the inverse cosine of negative square root. So now we're looking at our example for where the x value is negative square root 2. Now it is that exact angle we just found. So 5/4 does have an x value of negative square root 2. However, is this in our restricted domain? No. So we have to keep it. Where else do I have negative square root 2 over 2 as the x? 3/4. Is this in our restricted domain for cosine? Yes, this is my answer. This is what I would input. Any questions on this one? Okay, no, just because I want us to be solid on this. So here, do I want to do this one? No. Do I want to do this one? This last one. Yeah. Okay. Yes, I think I do want. All right, so part D. Sine inverse sine of 1/2. Meaning we're looking for when the y value is 1/2. So where on your unit circle is the y value? Pi over 3. The y value. Pi over 6. Yes, we keep switching those. Is that pi over 6 in our restricted domain? Is this in our restricted domain for? Yes. So this is our answer. We also could have said, and sometimes we said it above, 5 pi over 6 is also having a y value of 1/2, but that is not in our domain. So we have to take pi over 6. And now we're finding the tangent at that angle, knowing that tangent is always y over x. So at pi over 6, you're taking your y value and you're putting it over, whoops, that's a 3 value. Now this one's a little harder because can I read my answer like this? Have to simplify it. How can we simplify? Because you're taking the tangent of I over 6. Anytime that we have a number that has I in it, it tells us that this is not a value, it's an angle. So you're looking on your table for the angle pi over 6, right? And we're trying to find tangent of that angle. Tangent is all y. So at the angle pi over 6, the coordinate point is square root of 3 over 2, comma 1/2. So what I did was I put the y value of 1/2 over the x value of square root of 3 over 2. That's what we ended up with. Does that clear it up a little? Okay. So yes, Kate was right. We have to multiply by the reciprocal. Ooh, my thing is, so we're multiplying by the reciprocal, meaning we keep the numerator and multiply by the reciprocal of the denominator. Now, anytime we're multiplying fractions and we see there's a like term between the numerator and the denominator, they cancel, leaving us with 1 over square root of 3. Can I leave my answer like this? No, right? We have to rationalize the denominator by multiplying by the square root of 3. And we get the final answer of square root of 3. That's what we would input into